Before we start, learning mathematics is like life. So, what is life? In math, life plus love equals happy. And life minus love equals sad. So, 2 life divide 2 equals happy plus sad divide 2. Therefore, life equals 1/2 happy plus 1/2 sad. That's real life. Enjoy it. So with no further ado, let's begin. Functions and relations is one of the most important topics in algebra. These are the two different words having different meaning mathematically. You might get confused about their difference. Before we go deeper, let's understand the difference between functions and relations. Function is a relationship between sets of variables x and y such that each value of x corresponds with an exactly one value of variable y. In math, a function is an equation or expression that includes one or more variables or unknown numbers, and the output of the function, the answer to the express, will depend on the input or the number used in place of the variable. Take note, all functions are relations, but not all relations are functions. Examples of functions. Functions are often notated with an f of x. This means the function of x, where x is the variable. A simple function might be notated this way. Number 1, f of x is equal to 3x. The function is to multiply by 3, so for every value that is put in for x, the output or answer will be different. Number 2, f of x is equal to 2x plus 3. The function is to multiply by 2, then add by 3. So, for every value that is put in for x, the output or answer will be different. Number 3, set x is equal to the set of teacher, table, ballpen, pass. And set y is equal to the set of student, chair, notebook, failed. The result is a set of ordered pair in the form of x and y. Therefore, f is equal to the set of teacher and student, table and chair, ballpen and notebook, pass and failed. Number 4, f is equal to the set of 1 and 2, 3 and 4, 5 and 6, 7 and 8. The last example shows that each value of x corresponds with exactly one value of variable y. Relations. A relationship between sets of x and y variables such that a single x variable is associated with more than one value of variable y. A relation between two sets is a collection of ordered pairs containing one object from each set. If the object x is from the first set and the object y is from the second set, then the objects are said to be related if the ordered pair x and y is in the relation. A relation is any set of ordered pair numbers. An ordered pair number is a pair of numbers that go together. The numbers are written within a set of parentheses and separated by a comma. For example, 2 and 3 is an ordered pair number. The order is designated by the first element 2 and the second element 3. The pair 3 and 2 is not the same as 2 and 3 because of the different ordering. Sets of ordered pair numbers can represent relations or functions. Another example of relations. The first diagram is an example of one-to-one relation as a function. One-to-one relation. Each element of the domain is being traced to one and only element in the range. For the second diagram, what do you think? Does each value in the domain point to a single value in the range? Absolutely. The second diagram is an example of many-to-one relation. There's nothing wrong when three elements coming from the domain are sharing a common value in the range. This is a great example of a function as well. If you think diagram 3 was bad, this is worse. A single element in the domain is being paired with two elements in the range. Remember, if an element in the domain is being associated with more than one element in the range, the relation is automatically disqualified to be a function. Thus, this relation is absolutely not a function. And the last diagram is an example of many-to-many relation. We say, several elements in the domain have many elements in the range, and several elements in the range are associated with many elements in the domain. Next, examples of relations. Direction. Complete the x values for tables below. Given 2y equals x. The y values are 2, 3, 6, 8, and 7. To complete the x values, substitute the y values to the given 2y equals x. Solutions. Using the first value of y, which is 2, we have 2y is equal to x. 2 times 2 is equal to x. Therefore, x is equal to 4. And for the second value of y, which is 3, we have 2y is equal to x. 2 times 3 is equal to x. Therefore, x is equals to 6. And for the third value of y, which is 6, we have 2y is equal to x. 2 times 6 is equal to x. Therefore, x is equal to 12. And for the fourth value of y, which is 8, we have 2y is equal to x. 2 times 8 is equal to x. Therefore, x is equal to 16. And for the last value of y, which is 7, we have 2y is equal to x. 2 times 7 is equal to x. Therefore, x is equal to 14. Answer. Last example of relations. F is equal to the set of 2 and 4, 1 and 3, 2 and 6, 0 and 1. The last example shows that two ordered pairs have the same x values. Cartesian plane is a method most commonly used to sketch the graph of pairs or real numbers using two number lines. A Cartesian plane is a graph with one x-axis and y-axis. These two axes are perpendicular to each other. The origin is in the exact center of the graph. The numbers to the right of the zero on the x-axis are positive. Numbers to the left of zero are negative. For y-axis, numbers below are negative, and numbers above are positive. The four quadrants of Cartesian plane are: first quadrant, top right, positive, positive. Second quadrant, top left, negative, positive. Third quadrant, bottom left, negative, negative. And the fourth quadrant, bottom right, positive, negative. Vertical line test is a method used to determine whether the relationship between the given sets is a function or not. The vertical line test supports the definition of a function. That is, every x value of a function must be paired to a single y value. If we think a vertical line has an infinite set of x value, then intersecting the graph of a relation at exactly one point by a vertical line implies that a single x value is only fair to a unique value of y. In contrary, if the vertical line intersects the graph more than once, this suggests that a single x value is being associated with more than one value of y. This condition causes the relation to be disqualified or not considered as a function. So here's the deal. If a vertical line intersects the graph in all places at exactly one point, then the relation is a function. Here's the example of relation that is also a function because it fits the vertical line test. Number 1. Graph of the line f of x is equal to x plus 2. Using x is equal to negative 2, negative 1, 0, 1, and 2. Solutions. Using the first value of x, which is negative 2, we have f of x is equal to x plus 2. F of negative 2 is equal to negative 2 plus 2. Therefore, f of negative 2 is equal to 0. For the next value of x, which is negative 1, we have f of negative 1 is equal to negative 1 plus 2. Therefore, f of negative 1 is equal to 1. And for the third value of x, which is 0, we have f of 0 is equal to 0 plus 2. Therefore, f of 0 is equal to 2. And for the fourth value of x, which is 1, we have f of 1 is equal to 1 plus 2. Therefore, f of 1 is equal to 3. And for the last value of x, which is 2, we have f of 2 is equal to 2 plus 2. Therefore, f of 2 is equal to 4. Here's the graph of the line f of x is equal to x plus 2, using the value of x values and the y values. The graph forms a straight line. To check if the graph is a function, we use a vertical line test. Since there is a one point of intersection, the graph is a function. So here's another example of relation that is not a function because it fails the vertical line test. Number 2, graph the sideway parabola using the x values which are 0, 1, 2, 1, and 2. And the y values which are 0, 2, 3, negative 2, and negative 3. The graph forms a parabola that opens right. To check if the graph is a function, we use a vertical line test. Since there are 2 points of intersection, Therefore, the graph is not a function. Take note, if a vertical line intersects the graph in some places at more than one point, then the relation is not a function. Mapping is another way used to show whether the relation is a function or not a function. A mapping diagram can be used to represent a relationship between input values and output values. A mapping diagram represents a function if each input value is paired with only one output value. Examples. The first diagram consists of two parallel columns. The first column represents the domain of a function, and the other column for its range. Lines or arrows are drawn from domain to range to represent the relation between any two elements. A function represented by the mapping, in which each element of the range is paired with exactly one element of the domain. The relationship of this diagram is a function, and it is an one-to-one mapping. And for the second diagram, in the mapping, the second element of the range associates with more than one element in the domain. If the element in the range that have mapped more than one element in the domain, the relationship of this diagram is a function, and it is a many-to-one mapping. And for the last diagram, in this mapping, the first element in the domain have mapped with more than one element in the range. If one element in the domain map with more than one element in the range, the mapping is called one-to-many mapping. One-to-many relations are not function. That's all for functions and relations. Thank you.